Good evening, everyone. I'm Çağatay. We are going to present our EDA project, dog breed detection. During our presentation, we are going to go through 4 points: the problem definition, general information about our data set, explain our data, and finally, conclusion. Now let's define our problem, which leads us to the purpose of our project. When you see a dog that you like while walking on the street, but you don't know the breed of it, it might be difficult to find out the name of its breed, since there are hundreds of dog breeds. You might need to search many dog pictures to find out the one that you are looking for, so that this process costs you a lot of time and effort. And we realized that this topic is missing, and we wanted to study about it. With machine learning algorithms, it is possible to detect the breed of a dog with ease, surely by training the model with pictures. And now, my friend Mart will talk about general information about our data set. You may go to the next slide.
Hello, I'm Mart. I will give some general information. So we obtained our data set from Kaggle. Our data set has 20,600 dog images in total in GPG format. Other than the images, there was an annotation file which had some information about each image, such as size of the image and the class it belongs to. There are 120 classes in the dataset. Each is the name of a dog breed. The dataset had no separate test file, so we needed to split it ourselves. We are planning to split it by 50% for test and 85% for training. Since we are trying to classify an image within a range of many known classes, our problem is a multi-class classification problem. Next slide, please. Here we can see.
Matt,
yes.
Can I say something?
Yes.
In the previous slide, thank you for sharing the resource. It's very important. Always share the resource so somebody else can download or use the same data set, but providing some link. Okay, so there is no reference for the data set. So how can I find this data set? Do you understand?
Yeah, we have link on the next
okay,
slide,
great.
I think.
Okay, great. Thank you.
Here we can see a graph that shows the number of samples for each class. The class that has the minimum number of samples is Pekingese with 149 samples. And the one that has the maximum is Maltese with 252 samples. Even though we had 20,000 data in total, when it's split into 120 classes, we are left with 170 samples for each class on average. Other than that, not all images had the same size, so we need to rescale the images as well. Now, Valid will continue.
Can I ask a question?
Yes.
Yes. So, Kemal, do you think that it would be enough, this number of samples for each class, to classify how many classes there are? 20?
120.
120 classes. Do you think that it will be done?
I don't really think it's enough, but we are thinking about some data augmentation or using like ImageNet images to improve our data set.
Okay. So I have another question for you, because you are doing the EDA, Exploratory Data Analysis. Do you think that there are some breeds are very close to each other so that their image sets can be combined in under a new combined label? Is that possible?
Actually, there are some classes, some dog breeds that look like each other. For example, the white ones, the white fluffy ones. I don't remember the names of it, but
okay.
I don't think we need to combine them because they are different breeds. They have different names and stuff. So
I'm sorry, Professor Murat. I've personally had a look on the.
Really? Yeah. Is your name first?
It's Valid. I'm really sorry. It's Vilid.
No, just remind me.
It's okay.
Okay.
So I had a look on the images in the data set, and actually the numbers of pictures, you might say they're not enough for now, but we're planning to do the work on 2 versions, the first one and the second one, while gathering data, so we won't have any delays. Now, regarding your question, there are different pictures, different positions that might at least differentiate one from another. And by our participation in trying to find more pictures to attach, we might not have to actually merge 2 breeds in one, as they are different in names.
Okay, so I don't know if you are gonna provide some images from these breeds, because there are 100 blah blah number of classes. It's not easy. Maybe you might think of decrease the number of classification labels, maybe, with just combining or some of the classes as one class. I don't know. Or maybe you select some of the classes so that you can augment the number of samples by using another resource, which provides images for these classes.
Well, I've noted that down. Thank you so much.
So just keep in mind that, okay? Just keep in mind that, okay?
Okay.
A suggestion for you, Mart, okay?
Okay, thank you.
Okay, please continue.
So, Vilid, it's Vilid again. Good evening, everybody.
Okay.
I'm going to be talking about a convolutional neural network. So, in case you know or do not, CNN is a deep learning algorithm which can take in an input image, assign importance to various aspects in the image, and be able to differentiate one from the other. Hence, CNNs use image recognition and classification in order to detect objects, recognize faces, etc. And the reason we will be using CNN is for the following. Number one is a method used for image classifications, as we believe it's a useful method since our data set is an image-based data set, which comes to the second point, the beneficial part of it for our data set. We have various pictures of dogs, and we need a method that can do this job clearly. So finally, as mobile programmers, we believe that the data set could be better explained by Bilge, so I'll leave the mic for her.
Okay, thank you.
Hi everyone, it's Bilge. You can see our data link. I want to start to say all photos are taken from ImageNet. And dataset consists of 2 files. First, annotation, the other is the image. Every image has own annotation file. Annotation file consists of XML code as follows. If you want, I can show the XML file, teacher.
No, you can continue with the presentations. Okay.
Okay. Annotation shows the picture of the, for example, Chihuahua dog, and its height and width and also depth. So first, I wrote a Python code and converted all these files to CSV form. I used Google Colab environment. And I used a read.csv function to create data frame. Here you can see the data table. These are our metadata.
Did you create by yourself?
Yes.
Bravo, thank you. Bravo.
When I look at the table after converting the file, there were spaces. So I created output without adding, you can see teacher here. Yeah. There was some spaces, so I wrote like that to achieve the perfect output, you know.
Okay.
First, let's see what the distribution of our data is and what values are there. we use the histogram function for this.
So these histogram function shows for each sample, right?
Yeah.
For each sample, for each image, right? Without considering the classes.
Mm-hmm.
Okay.
You can see our metadata, and histogram function shows us that the tree means it's colorful. The picture is colorful.
Correct.
And height and width it's a different because our image size is not all images are not the same size.
Not in the same resolution as well.
Yes. If you want, I can show the pictures.
Please continue. Please continue
Okay.
with your presentation. I will ask questions later.
Okay. Okay. I wrote a Python code to show you a dog random image. You can see. And this is another dog, and you can realize they are not same shape, but same depth, because they are colorful but not the same size.
Okay.
You can see from here. So our data is balanced or not. So I can show you our data set are not balanced. This Chihuahua class, you can see 152 rows, but in here, African hunting dog has 169 rows. So so our data set are not balanced.
But it's not too much difference.
Yes.
Right. So one is not 1,000, the other is not 200, for example.
They are similar, but not the balance. I can't say not.
Not exactly the same number, but it looks like a little bit difference, right?
Okay, I want to explain what is directory structure to my friends. In computing, a directory structure is the way an operating system arranges files that are accessible to the user. But now I want to express in this different way. There's a standard way to lay out your image for image data for modeling. After you have collected your image, you must sort them first by data set, such as train, test, and validation, and second by their class. For example, imagine an image classification problem where we wish to classify photos of dogs based on their feature. This code taken from Stack Overflow, because I never know that the directory structure. I never heard before, but as you send message, as you send mail to us, so I wanted to put the code and output here. I actually showed the image size are not same, but I wrote a code to prove that it's not same, but the depth is same, but image is not.
I see.
And if you ask me, there's a missing values or not? Yes, there's a missing values. This code it shows is the true, because we have a missing values. And before I finish, I want to talk about our concern about this data. What our teacher Murat Karakaya taught us this: your data set, that is subset, must contain at least one of all the things in the universal set. But in this data set, for example, there is no Sivas Kangal dog.
Yes.
I mean, if we think of dogs all over the world as a universal cluster, our data set not include all dog breeds. which means we will fail the test parts.
In a real life situation.
Yes, and we don't think we have enough samples of our project, as Murat Karakaya said to us. So we would like to get our teacher's opinion on these issues. And thank you for listening to us.
Bilge, could you please go at the beginning of your presentation? Yes, yes, here. One slide before. Yes, here, my suggestion for everyone is that when you try to provide some EDA on your data set, if you go over each sample, it's not easy to understand, right? But maybe after showing these, you might want to cluster the labels and then show their average values. Do you understand? If you put these, for example, for the width and height values of each labels, maybe we understand that for this kind of dog breed, the pictures are all in that size. Do you understand? But in that label, maybe the width and heights are different from each other. So when you provide some plots like that, please consider provide the plot in the labels axis. So for each label, provide an average value. Do you agree, Bilge?
Yes, I totally agree.
So next slide, for example, here the same. You can use, for example, providing the height for each class averages. It is done with ease, believe me, that in Python, 2 lines of code. That's all. You can do it.
Yes.
And let's continue. Here is the same, because by looking all the numbers, you cannot gain insight. Don't forget that we focus on classification of images. Am I right? And actually, we need to understand that if the classes, the labels, are different from each other or not. Therefore, we need to focus on each label. When you provide some statistical information, use all the images under this label, find average, minimum, maximum of in that images, then provide the results with respect to or per images, classes, labels.
Yes, you are totally right. Because so, this is the first time I...
I understand. So I want to improve you this beautiful presentation and insights by adding up these analysis, and then add these analysis into your final report, okay?
Okay, so we're gonna add all these things our final thing, right?
Please add up and increase. So as you created already a CSV file, as you suggested at the beginning, you can work on easily, right? Just select the, I don't know, some dog breed and summarize the statistic about that label and compare the results with the other labels. Then you would understand that if it is really different or not. And for the image directory, if you go the directory structures, next slide, I believe. Yes, here you didn't provide the, for example, how it is designed in train data set, test data set, validation, are they designed structure in a way or not? I didn't understand.
I did, but I didn't include the slide.
Okay. Then include into the final report. So you could show that the structure is like that, blah, blah. Okay. So
because I wasn't sure that we need to add this everything in this EDA presentation.
Yes, EDA means that you need to gain some insight, whatever the insight is.
Okay.
Maybe you would notice that only there is the train and test data, but no validation. So then at your work, you might think that split the train data into train and validation. So you need to mention, okay, in that structure,
Yes,
All right?
and I want to also show you the, for example, I'm sorry. You can see.
Yes. My last point is that actually you didn't show us the samples, real samples from that.
Yes, and I want to tell you, our pictures are just not only consist of a dog. There's also human here. So we need to create a model which detect the dog in this case.
Recognize the dog. And
Yes, recognize the dog. Yes.
Yes, that's my point for everyone. So you need to take care of the images, maybe like that, one by one, as much as you can do. Then you gain some insights. So selecting random images and take a look at them will help you a lot, because somebody thinks that the images are only including the dogs, but you see that there is a family.
Yes, you can see there's a family here.
Yeah, so you need to mention in your EDA as well.
Yes.
Because you need to take care of them, as you suggested in your model as well. Maybe, just maybe you will drop this kind of images, right? Maybe you can use these images in train, but maybe you don't want these kind of images, the family images, in the test. Or maybe you remove both of them. Do you understand my point? Do you understand the importance of checking?
Yes, I really understand, but you told us you need to select, you need to decrease the classes.
I didn't say that you need to decrease the class. I suggested that to combine some similar classes into under one label, because the number of samples are few. I'm saying that, for example, the breeds ABC maybe are very close to each other. An expert would say, I wouldn't say this. Then you put these ABC in one directory and call this new breed ABC breed. Do you understand? Now you have not 150, but now you have 450 images.
Yes.
If they are similar, I don't know. I'm not a dog expert. So that's the EDA. You need to think of like these things.
Yes.
Okay. So thank you, Bilge. So anybody would like to add up something with it?
Professor Mart, Billy speaking. So when do you think we have to drop some images of a class? Is it when, like, speaking of this example, let's say if a number of pictures in this class is 200 and there exist only 20 pictures of a dog with a family or with a human.
I see your point. It's a valid question. Could you please go up to, I think it's a couple of first slides showing the number of from each classes. No, not that one. I think at the beginning, very beginning. Yes, here. So you have at least 150 images for each class, I believe, right? Almost.
True.
Okay. So if you want to increase the number of the images for each class, it wouldn't be easy to collect these 200 classes. I don't know how many. How many classes you have on total?
120.
So it's not easy to collect 120 dog breeds images from the internet. You have these one, okay? But maybe, I am saying maybe, two ways possible. One is that you can just combine similar breeds into one class, and then so you increase the samples. Or you can select some labels, some dog breeds, which you can find other images from other sources. Then create, for example, 10 breeds classes. Okay.
I see.
And
yes.
as Bilge mentioned that we know that in the world there are maybe, I don't know hundreds or maybe thousands of different breeds, dog breeds. It's not easy to collect images from each of them. So it's not easy, but it's a, graduation project. We can consider, for example, saying that in the project report, we are limited with 10 of breeds because we begin with that data set and we consider that we are not able to increment the number of samples for each 120 images classes. So we decided selected the 10 breeds, and then the increase of each samples in that breeds, for example, 1,000. It would be okay. These are the two suggestions for you. If you cannot make it, continue with that data set because we already started.
Okay.
Is that clear, everyone?
Okay, teacher.
Yes.
So also let me, if you like, let me share my screen. And
yes, I'm stopping sharing.
Please, I think you see my screen right now.
Yep.
Yeah. So as I suggested that for the image data set, you can do several activities on them. So as I said that, please check that if the images are corrected, labeled. For your case, for example, when you check that, you will understand that in the images, not the dogs exist, but some other things, families, houses, cars exist. So it's important for you. Then you can check this by visualizing random images as you did. Okay. So for each class, you can think sample numbers. So you get how many numbers from each set, so you could understand the data set is balanced or not. Because if it is not balanced, as BG suggested, you need to use some other metrics to evaluate your performance. Okay, it is important.
But teacher, but we already did, right? I think I did.
Yes,
I checked sample numbers for each class.
BG, I am not saying that you forgot it. I am just
okay.
So for the image and size, color, etc., for each sample, and if they are the same or not, check this. If they are not the same, then please report per class. Okay, not per samples, per class. So compile them, get the averages, minimum, maximum values for whatever, then report them for each. Not for each sample, but for each class label. Okay. And then, as I said, that always check that if you can differentiate the samples in different classes by your eyes. If it's not possible, then how can the model would do it? Okay. And we talk about the image directory structure. Check that if there is a validation set already, or sometimes you don't have the train and test split. You need to check and understand this, okay? In metadata data is saved most of the time in a CSV file. Check that CSV file as well, okay? That's my suggestions. That's the email that I sent. I share with everyone. So please use these resources, all right?
Sure.
So do you have anything to add up?
No, thank you for listening. And I'd
thank
like
you
to
for
thank
listening,
others.
sir.
Okay, thank you. It's a good presentation. Bilge, thank you for Velit, Çağatay. Okay, it is very good presentation, but please improve your data set and your approach to data set, and please note these discussions into your final report right now. Okay, Velit?
Thank you.
Surely. One last question. I'm really sorry. Will you be uploading this video on YouTube so we can review?
Yes, of course. In a couple of days.
Okay, so much goodbye.
Right.
It's okay.
Okay. So thank you. We will continue with the next group. Okay.